Hello, welcome. My name is Przemysław Rzepecki and I'm recording this in Stockholm, Sweden. This is the first video of Sunday DoJo series. Well, we will make some simple coding exercises here with hope to improve our programming skills. Today we will start with Fibonacci numbers. This is very simple series of numbers. You see some initial values on this web page. Try to implement it. So I just run the configuration script. You can see I'm using the WAF build system, and we open our test file. We start with writing the test. So we'll be using the test-driven design, and we are using the Google test framework. So let's include the header file, and we need some implementation. Let's put that in the Fibonacci.h, and we write our first test case. Let's test the initial values. So let's make sure that the 0 match the Fibonacci number of 0 and 1 match the Fibonacci number of 1. Let's also use an object for representing this Fibonacci series. Let's put the object f, Fibonacci object. And yes, we are missing the implementation, so it doesn't compile. We need to open the header. Let's create a class. Don't need anything in the constructor destructor. Just put the empty functions there. But we would like to call our object. So we will use our object as a function. And for that one, I just added the operator, call operator. So we have like a functor here. And just to make our test case pass, I check if the input value is equal to 0. We can return 0, else we can return 1. That should make the test case pass. Yeah, it's passing. Let's add some more tests. So other things about Fibonacci numbers is that they follow a recursion rule. So I create the simplest possible test case to validate that. And we check that, let's say, Fibonacci of 20 will be a sum of Fibonacci 18 plus Fibonacci from 19. So 19 is Fibonacci number. Let's see if that test case missed our object. See if the test case failing. Yeah, it's failing. Doesn't hold. Let's try to implement this recursion rule. So if n is 0, we'll leave it at 0, and then n equals to 1, we return 1. Otherwise, we need to return the value. Okay, else we call ourselves, so our own object with the n-1 or n-2, and we return the sum of it. Just correct the formatting. That looks quite nice. Oh, great, the test case is passing now. But I'm still not very confident that the implementation is correct. So let's check it against all the known values that we have. Let's go back to this web page, and I grab all the values that they have provided. We paste it into our test case, and let's try writing one assert statement for every of those numbers. So I just change all the comma to a new line, and then we will insert this assert statement at every line. So assert equal open bracket fixed. And now I would need to add the second part, so make this call to our f object on the right side. I mark all the lines, put comma, f, call. We'll need to close the assert parenthesis. Okay, now we also need to fill the sequence of numbers to put in the into this call to our f object. And for that one, I write very small Python script just to get the serious number. So put this one line, filter it through Python, grab the numbers, and we just paste it there. That should work. I just removed the empty lines from the left and correct the indentation here in this test case. Yeah, that should make it. So let's see if the implementation is correct. A lot of compilation errors. Of course, I forgot the Fibonacci object. Yeah, it's running, but you could see it's running very slow. We need to wait like 2 seconds to compute this few numbers. So let's write a test case to address the performance. Let's see if I will be able to calculate the Fibonacci number of 50. I'm not interested in the value, so I just check that something is returned. Yeah, it's running. It's taking very long time. Okay, let's just abort. Clearly we have problem with performance. You can see that for every call to Fibonacci we put 2 new calls on the stack, and then we'll make the very large number of calls to this function. We could address it putting some cached values. So let's add a vector of values, vector of values that we already computed. Then we will not need to call the function so many times. That's maybe not the simplest solution to that problem, but let's try it. So we have our vector of values, and then we first check if we have any values or a value calculated for given n. If it's not 0, then we can use it, else we will do our calculation. And once that's done, we could simply return the values from n. I think that should work. Oh, now you can see it's very fast, and all the values are still correct. Check if higher value will also work. It's very fast. Good. And if I make 20 of those, works fine. Now we add some limitation to our implementation, so we cannot call f from values more than 1000, and obviously we cannot call it with the negative numbers. So let's check that our implementation behaves correctly when this error happens. So we should cast an exception. I add the test case, and the exception is not cast at all. But that should be easy to fix. So I added the code to check if it's less than 0 or n is more than 999. You should throw an exception, and we just use the standard exception. C++ comes with quite many standard exceptions that are very handy to use. You don't need to declare a new exception class. So you just write out of range, and let's say value is not correct. Need a header file for it, standard except. Okay, now the exception should be cast. Yeah, the test case is passing. Let's add some more values here, so we check -2 as well as some very big negative number, and let's do the same for the values more than 1000. So 1000 is the first value that should throw an exception, and 1001, and then some very big number. Okay, all those throw an exception. That's very good. One other thing that we could do with Fibonacci number is to start counting from some other initial values. So we add a test case for it. I call it other initial values. like to declare our Fibonacci object now with the two other initial values, let's say 2 and 2. And then two first numbers in our series should be, well, 2 and 2. So Fibonacci of 0 is 2 and Fibonacci of 1 is 2. But that doesn't compile. We don't have the matching constructor. Let's include the numbers here. So we'll have n0 and n1. We should store those values somewhere, so I just create two new member variables. Let's call it first and second. Yep. Just make the line shorter. Add the members, first and second, and obviously we need to return them. If the n is equal to 0, we return the first one, and well, n is equal to 1, we return the second one. Let's try it. Now it doesn't compile still. Oh, of course, now all the other places when we put the Fibonacci object without the values will fail. So let's use the default one, so we will not disturb the old code. Okay, now the test case is failing, passing. But we just checked the initial values for this new type of Fibonacci number. Maybe we could add the other type of Fibonacci number also to this recursion test case. So I will add the G and H here, and we count, let's say, from 2 and 5 in G, and in H we will count with some negative values. And it's good to check this recursion holds for all the whole range of supported values. So we add the for loop, count from 0 to 1000 or 999, and we will check that this recursion holds. So I need to replace the fixed number here with our loop index, -1, I -2, and we do the same for H of G and H. Okay, I need to start counting from 2 as we have -2. Yeah, it's passing. So we made quite many test cases. You can see that the code coverage is 100%. Let's see this in color. All test cases are green. Seems that we are ready with our implementation. So thank you very much for watching. I hope you enjoyed the video. Bye.